Hello, my name's Allan Jude. I'm CTO at Clara. I do FreeBSD and ZFS development. And today we're going to talk about VDEV properties. So as anyone who's used ZFS for a while knows, properties are a great way to express administrative intent. Basically for the administrator to tell ZFS how the administrator wants ZFS to manage the things, whether that's what compression to use, what the quota should be, or whatever different aspect of the file system volume or pool that you're trying to control is. And the user interface for properties is also very rich, allowing you to extract data from those properties as both human readable as a human interface, but also provides nice machine readable output that you can hook up to a metric system or something to that effect. And so after playing with that for a while, I decided that VDEVs should have properties in that same vein so that you can control them and also get information out of them in both human and machine readable ways. So to start, I was like, well, what properties could we have on a VDEV? The first, when I started looking, was that in the struct VDEV that each VDEV has, there's a whole slew of counters that provide a lot of really interesting data about how many reads and writes and frees and other operations have been done on that VDEV. And those even percolate up to top level VDEVs. And so there's a lot of useful stuff there, but even other more stuff that's built in that's not necessarily exposed, like the enclosure path or the physical path to that device, rather than just the VDEV's name. So by exposing all of those, you're now able to get all that information about one or more VDEVs in this nice human and machine readable output. Then we added some writable properties so you can actually control how the VDEV works. And then user properties so you can store whatever arbitrary kind of key value data you want to store about a VDEV. And in my case, I actually store the partition scheme as a property. So when I'm replacing the disk, the automation can pull out and apply that same partitioning scheme. And the other thing I've always wanted was there's a lot of data in the zpool status output, including a bunch of counters for each VDEV about how many read and write and checksum errors it's had. But the output format of zpool status is not very conducive to machine reading. And so by exposing those properties, we can now read all of that in a more machine readable way and hook it up to metrics and monitoring and so on. So to start, the number of properties you can actually set on a VDEV is pretty small. What we have hooked up so far is a comment where you can just put some arbitrary free text about the VDEV. The path, so this is normally dev SDB or dev disk by ID and the path, but sometimes you want to change that and you don't necessarily have the ability to export the pool and re-import it with the -d flag to force it to pick up the VDEVs from a certain directory. So basically allows you to change the path in the zpool config that it will try first for opening that VDEV. So next time you import it, it should pick up from the correct path. And then in a few minutes, Mark will talk about the allocating property and how that works. And then, as I mentioned, we have the user properties. So you can just set whatever extra information you want to control about a VDEV in there. And then the future, one of the original ideas we had was moving some of the per VDEV queuing information. So like maximum number of asynchronous reads that are outstanding, moving that from a currently that's a system-wide tunable into a per VDEV tunable. So if you had, say, a pool that mixed some hard drives and some SSDs, you could have different values for those different things, different VDEVs. And then for reading, there's quite a few properties that I managed to expose. In addition to being easy to get the device's GUID and its ID, you can get the physical path or the enclosure path, the serial number of the disk, its parent VDEV and its child VDEVs, and how many children it has, how big it is, how much of it is free, how much of it is allocated. The boot size property, I don't think that feature made it over from Solaris yet, or from Illumos, but where you can control when ZFS partitions the disk, how big of a space it leaves for the EFI, but also the age shift of the device, how many read, write, or checksum errors or initialization errors, IOPS of each type, bytes read and written of each type, the expand size, the parity level, so you can query a random VDEV and find out if it's RAID Z3 or RAID Z1, how fragmented it is, how big it is, its current state, and whether it's in the process of being removed. Basically, anything that's kept track of in the VDEV is now added as a property so that you can inspect it easily. So if you do zpool get all the pool name and then one or more VDEV names or the special keyword all-VDEVs, then it'll print out a bunch of this information, and you can see, I have a VDEV here, 64% full. It's got 512 byte sectors. It's a 16 gig virtual disk. You see the original device name, its actual dev ID, the path, etc. And you see its parent is the pool itself, so it's a top level VDEV. And you can see number of read and write operations and so on. The properties are persisted in a per VDEV ZAP. That ZAP already existed. It was added as part of the device removal code. So VDEV properties doesn't require any new feature flags. And that top level VDEVs, so the meta VDEVs like Mir or RAID Z, can actually have properties as well. So you can apply properties to the top level VDEV rather than just leaves. And now we'll let Mark take over.
All right. So I'm going to talk about the allocating property, which is one of our writable properties. The allocating property, as Allan said, turns allocating off. It applies only to top-level VDEVs because that's the only allocating VDEVs you have in your pool. And VDEV has to have allocatable space in order to be allocating or non-allocating. The default, of course, is on. All top-level VDEVs can be allocated from by default. And setting it off prevents future allocations to the VDEV. So that means the remaining space on the VDEV is now unavailable. This obviously is going to impact the total available space in the pool. I'm going to talk some more about that here in a minute. One of the constraints with this property is that you must have at least one allocatable device in your pool. All right, this isn't about read-only pools. This is about allocating or non-allocating of a device. And so if you had were able to turn all devices as non-allocatable, that kind of would pretty quickly lock up your pool. So the primary use case for this new property is device removal. All right. So the current device removal process doesn't expose any notion of allocation directly or non-allocating directly, but it does it implicitly. So when you request device removal right now before this property, what happens is that the device removal code verifies that there's space available for device removal, and then it marks devices non-allocating internally. So it's an internal trigger that it has that allows it to set it non-allocating on a per device level, and then it removes the device by moving the contents of that device to the other devices in the pool. Then you could remove another device, etc., in a one device at a time sequence. Now that we have this property, and the reason we have this property is now you can actually do this sort of at a more efficient level. So if you want to remove multiple devices, you can set non-allocating or allocating off explicitly on those devices for all the devices, and that will immediately verify there's enough space to remove all those devices from the pool. And now you can issue your removals one at a time for those devices and not worry about getting new data into the device you're about to remove a little bit later. So let's go through an example of how that works. So here's a simple scenario. You have a config and you have a couple of old 4 terabyte drives, and you want to replace those with a bigger, faster 8 terabyte drive. Let's assume that each of your 2 drives are half full at the moment. So you want to, all right, well, you want to replace your two drives with device C. So the first thing you do is you add your new drive to the pool. And so dev C is our new 8 terabyte drive. And we have dev A and dev B is our two existing 4 terabyte drives, half full. This is the first step, is you're going to replace your two drives. And this scenario I'm going through first is without the properties. This is the traditional sequence you'd go through right now if you were to remove two drives. And so when you issue the z-pool remove tank command, you see that it becomes non-allocatable, and you see that it moves its data from that device onto the remaining drives in the pool. So in this case, dev B gets a terabyte and dev C gets a terabyte. So we've copied two terabytes of data, but we've done it inefficiently, because now when we go to move the second drive, instead of removing just 2 terabytes off of drive B, we now have to move 3 terabytes from drive A to drive C. So in the end, we end up moving 5 terabytes of data in order to get 4 terabytes of new data on drive C. So with the new algorithm, we're going to do the same scenario, except this time we're going to apply the allocating property, or the allocating equals off technique. So we add the drive, and now we set allocating off for A and B. And we can do this because we have drive C, so we still have capacity in this pool. And drive A and drive B are now non-allocating, but no data has been moved yet. We now issue remove command for drive A, and its 2 terabytes are again of data are moved off, but in this case, all that goes directly to dev C, because dev B is non-allocating. So we do 2 terabytes of copy, and now when we remove dev B, we only have 2 terabytes of data left to move, and those 2 terabytes go to dev C. So we were able to move the 4 terabytes and only move 4 terabytes of data, rather than having to copy 5 terabytes of data around. So this is an optimization, and you can imagine this could get pretty significant if you're doing a larger transformation on your pool. If you're moving or replacing a bunch of drives with newer drives, potentially, you could end up copying a lot more data around if you have to do it piecemeal. So for configurations with many drives in them, this can be a huge optimization. So why allocating, though, instead of read-only? Well, mostly because this does not make a device read-only, all right? It's still possible to modify a device that's marked non-allocating. You can still update its labels, and you can still even do scrubs on it, right? In place, data manipulation is still possible. It's just we simply have disabled the ability to allocate new space on that drive. It also impacts the pool space in a way that's different than what you would think of for read-only. All right, and the expectation for read-only would be, I am only going to remove the unused VDEV space. Only the unused VDEV space from that drive would be subtracted from the available space, meaning in our previous example, we had 4 terabyte drives. If you were to mark one of those 4 terabyte drives read-only, your expectation would be that your available space would decrease by 2 terabytes, because that was available space on those 2 drives, on each of those drives. So each drive would give up 2 terabytes of space from the total capacity of the pool. But the actual impact from marking something non-allocating is different. We subtract the entire capacity of the drive from the available space. Now, this is two reasons for this, really. One is it allows us to accommodate for an existing rewrite. So for example, if you were to mark a drive as non-allocating and then were to rewrite that data, your expectation would be that I wouldn't run out of space because I would be overwriting logically the data that's on that drive. But in reality, you're going to have to rewrite that someplace else because it's non-allocating now. And so this sort of takes care of that potentially odd oops moment you might have. But more importantly, from our perspective, this is because we are actually using this as a precursor to device removal. And so we need to make sure there's not just the capacity of the drive, but there's a full drive capacity available. So we're also, when we move that drive content, we're going to make sure we have enough space for it in another on the pool. Also, and so in general, just allocating is a more accurate name for this feature. I think that's all I had specifically talked about with respect to allocating. Allan, you want to come back in and talk about your last couple slides here?
Yeah. So yeah, the question is, what else could we do with this? Sorry. So the things that I've thought about that haven't done yet is obviously having support for channel programs to change the properties like you have existing. And a very commonly discussed idea is this concept of having a mirror read bias. So if you have a mirror with one of the members is actually remote via MetroNet or something, you'd want to try to have all the reads actually come from the disk that's local and not the one that's far away. But you might actually want to, rather than just say, you know, in this mirror, prefer reading off the first member, you might actually want to say, you know, each mirror member has the host ID of the machine that should prefer to read from it, so that when you actually do fail over to the other side of the metro, it knows, oh, I should actually read off what is my local disk, not what was the local disk of the original machine before we failed over. Another thing is currently libzfs does caching of all the pool properties, but does no caching of VDEV properties. I don't know if it makes sense, especially since pool properties, there's kind of one list and there's only ever one pool per libzfs handle. And so, you know, the amount of memory is kind of fixed. But with VDEVs, you know, it could be a lot to try to cache or to, you know, automatically load all those properties as soon as you open the handle. So it might not make sense, but it might be interesting. We've talked previously about having inheritance for properties. So far, there's not a use case where it is worth the hassle, but there might be. And another idea we had was currently the counters, like number of reads and writes and so on, are not persistent. They're just come from the VDEV-T. So they're only persistent through importing the pool. So if you export the pool and import again, the counters go back to 0. There might be some counters where we'd actually want to persist those and keep track of long-term how much has been written to this SSD, or, you know, how much have I been using this cloud so I can compare it to my cloud bill. But we'd also have to balance how frequently do we want to persist those out, because we don't want to create more write load by keeping track of how much write load there was. But the other question for the kind of takeaway is, what other settings could be VDEV properties? You know, there's quite a few tunables where we started to think about maybe these could be per pool or per VDEV, but what other things about a VDEV would it be interesting to be able to control? One of them that I've thought of is the special VDEVs, the metadata class stuff. Being able to control, if I have multiple special VDEVs, I want to say this special VDEV only holds metadata and this one only holds small blocks, or this one's only dedupe or whatever, with a bit more granularity than you have now. Or maybe that ends up being, rather than one setting that says it takes this type or that type, maybe there's special metadata equals on or off, special small blocks equals on or off, or whatever. Another question that I've brought up a couple times is, how many properties is too many properties? Do we end up wanting to have some kind of a flag on a property that's not necessarily hidden, it's just not displayed by default? So if you know, get that one, or, you know, we have a second keyword after all, like really all or something, to display them, there's a bunch of them where maybe it doesn't make sense to display this all the time, but if someone wants it, they should be able to get it. And then Pavel had asked about being able to set VDEV properties at pool creation time. Definitely could use some input on what the command line syntax for that should look like. You know, if I'm specifying a pool and it's going to have 4 different VDEVs, and I want to set, you know, this property one way on this one and a different way on a second one, how am I going to express that on the command line without making it overly complicated? And you can find me on Twitter or whatever if you have questions after.
Jorgen, would you like to ask a question?
Oh, I had a short one for Allan, actually. When you said you can change the VDEV property name,
The
Or
path, you
path,
mean?
right? Path, right? But that does not include physical path.
Correct.
Okay.
The physical path is kind of, that one's a bit more OS specific. Like I think on Linux, it ends up being literally like the PCI path or whatever. And it's a bit different. But the path in this case is like dev, whatever that you're opening.
Yeah. No,
And
the old one out here is obviously Windows, because path is cosmetic only. Like it's purely a nice string that the users see. It doesn't use it ever. And physical path is where we hide the ugly thing. But on the other hand, I'm not sure I want users to be able to change, the partition offset and the path name. It's
right,
kind of scary. So
yeah,
I'll have
if
to
they
think
need to
about
be
that
able
again.
to, it's easy enough to make the property not flagged read only, and then they can.
Okay, I'll think about it. But thank you.